Welcome to PRISCI-ANTO Educational Academy. In this session, I am going to explain the unitary matrix, the example of unitary matrix. Show that 2 by 2 matrix is given 1 plus I divided by 2 minus 1 plus I divided by 2. 2 by 2 matrix, first row. Second row is 1 plus I divided by 2, 1 minus I divided by 2 is unitary. Answer is, let us see what is unitary. The unitary is capital A, matrix A bar transpose. A bar transpose, which is equal to A bar transpose A, which is equal to I, identity matrix. A bar transpose, which is equal to A bar transpose into A, which is equal to I. So given the matrix A is equal to 2 by 2 matrix, first row is 1 plus I divided by 2 minus 1 plus I divided by 2. Second row is 1 plus I divided by 2, 1 minus I divided by 2. Next you have to find A bar, complex conjugate. So A bar means 1 plus I is there, you have to write minus I. So 1 minus I by 2. Minus 1 plus I in A bar minus 1 minus I divided by 2. 1 plus I divided by 2, second row first element in A bar 1 minus I divided by 2. In A 1 minus I divided by 2, but in A bar 1 plus I divided by 2. So A bar we have got A bar transpose, which is equal to, transpose means first row you have to write as first column, second row you have to write as second column. So therefore A bar transpose is equal to 1 minus I divided by 2 minus 1 minus I divided by 2. First row you have to write as first column, 1 minus I divided by 2 minus 1 minus I divided by 2. A bar transpose. So A bar, in A bar second row, in A bar transpose you have to write the second column, 1 minus I by 2, 1 plus I by 2. So A bar transpose over. Next we have to find A bar transpose. So therefore A bar transpose. A is that is given in the problem, 1 plus I by 2 minus 1 plus I by 2, 1 plus I by 2, 1 minus I by 2. That is A. A bar transpose, just now we have got 1 minus I by 2, 1 minus I by 2, minus 1 minus I by 2, 1 plus I by 2. These two you have to multiply. First row, first column you have to multiply. 1 minus I square divided by 4 plus 1 minus I square divided by 4. 1 minus I square divided by 4 plus I square minus 1 divided by 4. Second row with the first column, 1 minus I square divided by 4 plus I square minus 1 divided by 4. Second row, second column, 1 minus I square divided by 4 plus 1 minus I square divided by 4. 1 minus I square is minus 1. Already there is minus. So 1 plus 1, 2 by 4 plus 2 by 4. 2 by 4 minus 2 by 4. 2 by 4 minus 2 by 4. 2 by 4 plus 2 by 4. So therefore 2 by 4 plus 2 by 4, 4 by 4 will be 1. So 1, 0, 0, 1, which is equal to I. So it is a unitary matrix. Similarly, we can solve A bar transpose into A. A bar transpose into A means A bar transpose, first you have to write as it is 1 minus I by 2, 1 minus I by 2. Minus 1 minus I by 2 plus 1 plus I by 2. A is 1 plus I by 2 minus 1 plus I by 2. 1 plus I by 2, 1 minus I by 2. So first row multiply with the first column. Answer is 1 minus I square by 4 plus 1 minus I square by 4. First row, second column you have to multiply, minus of 1 minus I square by 4 plus 1 minus I square by 4. Second row with the first column you have to multiply. Minus of 1 plus I whole square divided by 4 plus 1 plus I whole square divided by 4. Second row, second column you have to multiply. 1 minus I square by 4 plus 1 minus I square by 4. So 2 by 4 plus 2 by 4. 2I by 4 minus 2I I divided by 4. Minus 2I divided by 4 plus 2I divided by 4. 2 by 4 plus 2 by 4. So answer is 1001. Hence, A bar transpose, which is equal to A bar transpose A, which is equal to identity matrix.